Okay guys, once again, we're going to do section 5.3. This from Math 35, section 5.3. In section 5.3, we are discussing polynomials. Polynomials, okay? Now, by definition, what is a polynomial? A polynomial is a sum of terms. When I say sum, I also mean subtraction, because subtraction is also a sum. We can express subtraction in terms of addition. So therefore, subtraction is also addition, okay? By definition, a polynomial is a sum of terms. And when I say sum, I also mean subtraction. So a polynomial is a sum and difference of terms, okay? Oh, forgot my pen. Let me get my pen. Okay, so what is a polynomial? Okay, let's just give some terms. For example, here we go. 3x squared plus 2x minus 5. That's a polynomial. But specifically, since this is 3 terms, you may call it a trinomial. Trinomial. A trinomial. That's 3 terms. If you have 2 terms, for example, negative 11x plus 2, this is also considered a polynomial, but specifically you may call it a binomial. So that's a binomial. If it's 1 term, we're going to call it a monomial. 1 term. 1 term is called a monomial. If it's more than 3 terms, we just call it by its general name. By the way, these are all polynomials. These are all polynomials, but you may call this one a trinomial, a binomial, a monomial. Monomial. If you have more than 3 terms, for example, negative 2x to the third plus 7x squared minus 11x plus 9. More than 3 terms, we just call it by its general name. In other words, 4 terms or more, we're going to call it polynomial. By the way, this polynomial, its degree is the greatest power of the variable. So the degree for this polynomial is 3. That's the greatest power. And this polynomial is in descending order. Look, 3 power for this variable is 3, power is 2, power is 1, and believe me, there is an x to the 0, so this power is 0. X to the 0 is 1. x to the 0 equals 1. So this x to the 0, which is 1, and that's 1 times 9, and what's 1 times 9? 9. So this term is of degree 3. This term is of degree 2. This term is of degree 1. And this term is of degree 0. The degree for this polynomial is the greatest degree of the polynomial. So degree for this polynomial, the degree is 3. Yep. The degree for this polynomial, the greatest power, 2. The degree for this polynomial is 1. The degrees for this polynomial, this is a polynomial, but specifically you may call it monomial. But if you call it polynomial, it's fine. What's the degree? 1. So these are polynomials, okay? Note, you gotta have, the powers must be positive. If any power is negative, it's no longer a polynomial. All the powers must be positive, okay? By the way, you see this, the numerical part of this term is -2. This -2, we call it a coefficient. And this term has a coefficient of -2. This term has a coefficient of 7. This term has a coefficient of -11. And this term has a coefficient of 9. So this polynomial is of degree 3. And it has how many coefficients? -2, 7, -11, and 9. Those are the coefficients. By the way, this -2 belongs to this term. They go together. 7 belongs to this term. This negative, you see this -11? This -11 belongs to this term. Okay? This -11 belongs to this term. This -11 is called the coefficient. This is the coefficient for this monomial. You see this trinomial? This is the leading term. We have it in descending order. Descending order, this is the leading term. Leading term. And this must be the leading coefficient. This is the leading coefficient. It leads. Okay? Leading term and leading coefficient. Okay, beautiful. Since we've already discussed the concept of functions, I like to give polynomials names. I do. I like to give them names. I do. These are names, okay? Okay, so I'm gonna erase this now because I need the room. And I like to give them human names. For example, I'm gonna call this polynomial. I'm gonna call this polynomial Frank. Frank. This F stands for franc. And franc is using the variable F. So this is franc of X. This is just a name. We're using function name. If you want to say franc, fine, call it franc. It's just a name. In mathematics, we say f of x. But since I want this to make sense to you guys, think of it as a name. That's just a name. What should I call this? Can I call this one Jack? J of x. J for Jack. Okay. This one I'm going to call it a name. Let me use a female name. What should I call this? Should I call it Norma? Norma. And Norma of x. And this buddy right here, what should I call it? Should I call it Anna? Anna of x. You see? These are function names. Function names. Okay? Function names. Now, those are good names because now I can use this notation and it's going to make it easy for me whenever I want you guys, for example, to plug in a value for the variable. For example, I may say to you guys, can you plug in, can you find out what franc of -1 is? Can you find out what Jack of -2 is? Can you find out what Norma of 3 is? Norma of 3. And can you find out Anna? Anna of what? Of 5. Anna of 5. Okay. Franc of -1. All I have to do is plug in -1 for x, wherever you see x in franc. Okay, no problem. This is -2 times x to the third plus 7 times x squared minus 11 times x plus 9. Okay. Let me rewrite Jack of -2 there, Norma of 3 there, and Anna of 5, because I need the rule, okay? So I'll erase this. All right, so now I'm going to plug in, this franc of -1. This is f of -1. That's what it is. Or franc of -1. So let's plug in -1 for x. X is -1, -1, -1. Can you see that? Okay. Now, please excuse my dear Aunt Sally, if you guys remember that. The order of operation says that I better raise this to the third power before I multiply. I better raise this to the second power before I multiply. Okay? So therefore, this is -1 to the third. What's -1 to the third? -1 times -1 times -1, that's -1. So this is -2 times -1. Plus 7 times what? That's -1 times -1. What's a negative times a negative? Positive. That's a 1. Okay. And this -11 times -1 is what? Plus 11. Plus 9. Okay. Continue. That's -2 times -1 is 2. Plus 7. Plus 11. Plus 9. I'm going to add those two. 2 plus 7 is 9. 11 plus 9 is 20. The answer is 29. So therefore, f of -1 equals 29. There it is. Let me find out what jack of -2 is. Jack of -2. There's jack. And now this variable is going to be -2. Here's the way I do it. Jack of -2 is the following. Okay, that's a 3 times -2 to the second power, right there, plus a 2 times -2 minus 5. Okay, since x is -2, I'm gonna plug in red -2 there. I hope you can see that, and -2 there. By the order of operations, I better raise this to the second power before I multiply. Please excuse my dear Aunt Sally. P stands for parentheses, E is for exponents. So therefore, I better take care of this exponent before I multiply. Okay, we can do that. So that's a 3, and -2 times -2, that's 4. 2 times -2 is -4, minus 5. I better multiply before, right? I better multiply before I add or subtract. So 3 times 4 is 12. And I can go ahead and add those two. What's -4 plus -5? Minus 9. Okay. 12 minus 9 is 3. So this is jack of -2. All right? Okay, we can do the other ones, okay? Might as well do the other ones. I have to erase this, okay? I have no choice. Gotta erase this. Sorry. There we go. And norma. Yeah, norma. Norma of 3. That's norma. Norma of x. Norma takes x, multiplies times -11, and then adds 2. That's what norma does. Norma of whatever this is. -11 times whatever that is, plus 2. Okay. But this one has norma of 3. Norma of 3 there, and so 3 goes there. And so now, multiply. -11 times 3. -33 plus 2, which equals to what? -31. Fun. This is fun. All right, gotta erase Jack. Sorry, Jack. Gotta go. Let's finally do Ana of 5? Ana is a lonely term. It's a monomial, one term. So Ana of x equals 7 times x. So if x is 5, this is 5, and this is 5. I hope you guys can see that. It's in red. So Ana of 5 is 35. There we go. Okay. Very good. All right. Okay. Now let's take polynomials. Okay. We're gonna add polynomials. We're gonna subtract polynomials. Yeah, that's what we're gonna do. Adding and subtracting polynomials. Okay. So, for example, watch this. I can take Frank and I can add it with Jack. Okay. I'm adding Frank and Jack. Okay, section 5.3 does not use this notation. Okay. But we know what Frank is. Here's Frank. So when you add those two, what's Frank? Frank is right here. Frank is negative 2x to the third plus 7x squared minus 11x plus 9. That's Frank. What about Jack? What's Jack? Jack is 3x squared plus 2x minus 5. Okay, so section 5.3 just gives you this. It says take this polynomial and add it with this trinomial. Okay? But in reality, it's Frank plus Jack. Section 5.3 does not use this this notation. Okay, but basically we're gonna get there anyways later on. So I'm just introducing you guys to the sum of two functions. In any case, here is Frank plus Jack. All we have to do is combine like terms and write the answer in descending order. Okay? So therefore, this equals to, this goes first because there is no other cubic term. This is the only cubic term. So this goes first, negative 2x to the third. I'm gonna take this is called a quadratic term. That's a quadratic term. I'm gonna add the quadratic terms. This is a quadratic term, and that's a quadratic term, and I'm going to add them. 7x squared plus 3x squared is 10x squared. That's a linear term, linear. And that's a linear term. I'm gonna combine those two. I am combining like terms. So negative 11x plus 2x is negative 9x. What's 9 minus 5? Plus 4. Okay. There it is. That's adding to polynomials. Okay. Watch this. Consider the following problem. Subtract Frank from Norma. Here I am subtracting two polynomials. That's what I'm doing. I am subtracting two polynomials. I am subtracting Frank from Norma. Okay? Subtracting Frank from Norma. I am subtracting Frank from who? From Norma. That's the way you write it. If you write it the other way, if you write it like this, that's wrong. This is wrong. Because here you're subtracting Norma from Frank. No. That's not what it says. So this is wrong. That's what we're going to do. Don't forget that now. Okay. All right, so let's get rid of this one. Okay. All right, we can do that. I better write Norma first. Here's Norma. Norma is negative 11x plus 2. Negative 11x plus 2. Okay. Minus Frank. Now, look at the importance of parentheses. Okay, watch this. Watch what happens if we do it the wrong way, without using parentheses. Watch this. Where's Frank? What's Frank? Oh, there's Frank. Okay? If you do not use parentheses, guys, if you do not use parentheses, it's gonna be wrong. Let me write Frank, okay? Here's Frank. Minus 2x cubed plus 7x minus 11x plus 9. Note, this is wrong. Because right now, you are only subtracting part of Frank. You see, you're only subtracting this term, which belongs to Frank. Parentheses are very important when it comes to subtraction polynomials. You need to subtract all of Frank. To subtract all of Frank, you use parentheses. And that's correct. Don't forget parentheses when you are subtracting. Okay. All right, let's finish it. All right, so here we go. That's Norma. Negative 11x plus 2. Now I'm going to subtract the first term of Frank. Subtract this term, and this term becomes positive. Plus 2x cubed. Subtract this term of Frank, and this term is positive, and it becomes negative minus 7x. subtract this term and it becomes plus 11x. Subtract this term and it becomes minus 9. Don't forget, guys, when you subtract, you better use parentheses around whatever is being subtracted. Okay? Now let's combine like terms. Combine like terms. Okay, that's gonna go first. I'm gonna write the answer in descending order. So that's gonna go first. So this becomes 2x cubed. That goes first. What goes second, guys? What goes second? Oh, by the way, did I forget something? No, I didn't. Did I forget something? Oh, yes, I did. I forgot this power, look. Power of 2 there and power of 2 there. I forgot it. No one said anything. Should have said something. All right. Got it? Okay, I forgot this power of 2. All right. So here's Norma right there. And here's Frank right there. I forgot this power of 2, but I got it now. Everything else is fine. This became positive, there you go. This became negative, there you go, and it's power of 2, look. This became positive, there you go, and this became negative, and there you go. Now I'm gonna combine like terms, and this goes first. There we go. This must go second, the quadratic term. Minus 7x squared, okay? All right. Hey, look at this negative 11x plus 11x, they cancel each other. Nice, I like that. Okay, and what is 2 minus 9? Negative 7. And there you go. That's subtracting Frank from Norma. Okay, let me pick a problem from the book, okay, because in the book, they're not using this notation, okay, but no problem. All right. So let me give you a problem from the book, okay? I need the room, guys. I need the room. There you go. Okay. So here's a problem from the book. All right, so here are a couple of problems from the book. Okay, I see. Look at this problem. Look at this. I'll give you that one first. I'll do this one instead. They have on page 384, self-check number 6. It says 9m to the 4th plus 16m squared minus, they're subtracting, they are subtracting. Look, subtracting parentheses. The book uses parentheses. 12m to the 4th minus what? 18m squared. This is page 384, self-check number 6. Okay. All right, I need the room, so gotta erase this. All right, let's do this. Give us an easy one, right? An easy one. No problem. Distribute like we did before. By distribution, this becomes 9m to the fourth plus 16m squared. A negative times a positive is minus 12m to the fourth. A negative times a negative is plus 18m squared. Okay. Combine like terms. 9m to the fourth minus 12m to the fourth is what? Minus 3m to the fourth. 16m squared plus 18m squared is gonna be 18 and 16, that's 28. Is that 34? Plus 34m squared. Okay. All right. Good. Nice. Okay. Look at this one. Here's a good one. Watch this one. Another problem. Negative 6a squared b cubed minus 5a cubed b squared minus, parentheses, don't forget that, 3a squared b cubed minus 2a cubed b squared plus ab squared, parentheses, close parentheses. Okay. All right, subtraction. Okay, now this is, we're subtracting terms, we're subtracting polynomials that have more than one variable. No problem. It's okay. All right, to subtract, distribution, okay? So let me rewrite this. Negative 6a squared b cubed minus 5a cubed b squared. And I'm going to distribute. Minus 3a squared b cubed. Because a negative times a positive is negative. A negative times negative is positive. Plus 2a cubed b squared. A negative times a positive is negative. Minus a b squared. All right. Okay, like terms. This has a squared b cubed, and this one has a squared b cubed. So this term and this term, they are like terms. Okay? I'm gonna add those two. I just add their coefficients. What's negative 6 plus negative 3? Negative 6, don't forget, those two are like terms. So I add their coefficients and I keep the variables to those powers. So negative 6 plus negative 3 is negative 9. That's a 9. Negative 9. Okay? Keep a squared and keep b cubed. So I combine this one and that one. Oh, I see a cube, b squared, b squared. So those two are like terms. So I'm going to combine this one and that one. Those two are like terms. Okay. So negative, to combine those two, I'll take the coefficient. -5 and a 2. What's -5 plus 2? -3. And I keep a to the third. A cubed, b squared. Okay. Oh, and it's all by itself. Minus ab squared. There it is. Okay. By the way, the degree for this term is the sum of the powers of the variables. So this term is of degree of 5. This term is of degree of 5. And what about this one? What's the degree for that one? Oh, 1 plus 2, that's a degree of 3. This term is of degree of 5. This term is of degree of 5. And this term is of degree of 3. Hey, what is the degree for this trinomial? That's a trinomial. 1, 2, 3, trinomial. What is the degree for this term? For this trinomial, what is the degree? The degree of the trinomial is the greatest power. It doesn't matter this one or that one, okay? Is 5. Okay. All right. I think I'm going to give you one more, and then we're done. Okay? Here we go. Let's try this one. Oh, they are using the, you know what, they are using the function notation, I noticed. Here we go. Oh, yes, they are. Yep. Okay. I need the room. This is the last problem, okay? This is the last problem. I need the room. So this is gone. Sorry, but it's gotta go. Here we go. Okay. All right. Here is a problem. They're saying this, look, f of x equals to 1/3 x to the 6th minus 1/6 x to the 4th minus 4/3 x to the 2nd. 1/3 x to the 6th minus 1/6 x to the 4th plus 4/3 x squared, or minus 4/3 x squared, minus 4/3 x squared. That's f of x. And then they say g of x is 1/3 x to the 5th, minus 1/6 x to the 6th, minus 1/6 x to the 6th, minus 1/2 x to the 4th, plus, I think it's plus, yeah, 5/6 x to the 2nd. Okay, they want us to add. Then they say take f of x and add it with g of x. But that's too easy. That's too easy, guys. Okay? Instead of adding, let's subtract. We're going to subtract, okay? Makes it a little harder. So there's a problem. Okay. No problem. What's f of x? Right there. 1/3 x to the 6 minus 1/6 x to the 4th minus 4/3 x squared. That's f of x. Minus. Remember what we said when we subtract? What did we say when it comes to subtraction? Parentheses. That's what we said. So g of x is going to be within parentheses. Parentheses. Don't forget. And what's g of x? Minus 1/6 x to the 6 minus 1/2 x to the 4th plus 5/6 x squared. Close parentheses. And because we're subtracting, distribute the negative. Distribute the negative. Okay? So this becomes 1/3 x to the 6 minus 1/6 x to the 4th minus 4/3 x squared. Distribute. Plus 1/6 x to the 6 plus 1/2 x to the 4th. What's the last one? Minus 5/6 x squared. Okay. Hey guys, look. X to the 6, x to the 6. They go together. Right here. This one and that one, they go together. I'm gonna, by the commutative principle over addition, you can put them together. Let's commute. Commuting over addition allows you to move terms anywhere you want. So I'm gonna take this term and I'm gonna bring it over. So this is 1/3 x to the 6 plus 1/6 x to the 6. All right. This one and that one. This one and that one. Okay. Put them together. This negative goes with this term. So this is gonna be, let me write this one first, and this one is positive. So this is gonna be plus 1/2 x to the 4th minus 1/6 x to the 4th. It's okay. You can write this one first and this one second, or you can write this one first and this one second. It's fine, because you can commute. Don't forget, the negative goes with it. This negative belongs to this term. This negative belongs to this term. And finally, this term and that term. Look, they're both negative, so it doesn't really matter, right? So therefore, I'm going to write this one first. Minus 4/3 x squared minus 5/6 x squared. Okay? Now let me show you a trick. Okay, I'm going to show you a trick. To combine those two, I don't know if I call it a trick. Okay, guys, to combine those two, they need to have the same denominator. No problem. For this to become a 6, this needs to become a 6. So multiply this by what? By 2, by 2. Okay. And now the 1/3 became 2/6. And what's 2/6 plus 1/6? What's 2/6 plus 1/6? 3/6. And keep the same variable to the same power. X to the 6. I'm not done, okay? I'm not done. Oh, there's another one. Combine those two. So then this one needs to become a 6. Because if it does not become a 6, you cannot add or subtract. No problem. That's an easy one. To become a 6, this needs to be multiplied by 3, and this needs to be multiplied by 3. Yeah? Okay. So now the 1/2 became 3 over 6. And what's 3 over 6? 3 over 6 minus 1 over 6. What is that? Is that 2 over 6? X to the 4th, right? 3 over 6 minus 1 over 6 is 2 over 6. 2 over 6 plus 1 over 6 is 3 over 6. Hey, let's combine those two. Wait a minute. This one needs to become a 6 because that's a 6. If you're gonna add those two, they need to have the same denominator. But you need to do it legally, okay? And the legal thing to do is to multiply this by 2 so that it becomes a 6. So multiply this by 2 and this by 2. I hope you can see that. I'm sorry, okay? You can see that. Now, the 4/3 became what? Sorry, the negative 4/3 became what? Negative 4/3 became 8 over 6. So negative 8 over 6 minus 5 over 6. What's a negative 8 over 6 minus 5 over 6? Negative what? Negative what? 13 over 6. X what? X what? X squared. Okay, I'm not done. Now I'm going to simplify. Okay? Simplification. Simplification, guys. I'm getting tired now. Simplification. Okay? 3 over 6 is what? 1/2 x to the 6 plus 2 over 6 became what? Becomes what? 1/3 x to the 4th minus, can you simplify that? No. 13 over 6 x squared. Okay. All right. And this is, guys, this is section 5.1 and 5.3. You guys can read and do 5.2. It's an easy one. Okay. Try those sections, 5.1, 5.2, and 5.3. Do the homework. I gave you a handout already. Okay, try the homework, okay? They are offering online tutoring from the math lab at RCC. You have to go to their website and find out what the hours are, and so therefore you take care of that. Okay, I have lecture today, 5.1 and 5.3. Okay, you guys can do 5.2. Okay, read 5.2 and do homework from 5.2. All right, guys, take care. Okay, hang in there. This is gonna be over sometime. Okay, soon. But life continues. All right, coronavirus is a virus. Let's take care of ourselves. Be careful out there. Okay, stay away from big groups. Okay, have a nice day.